Right, today's topic are water solutions of salts. And what happens when you put a salt into water, in addition to the salt dissolving in the water, the salt also hydrolyzes the water. So as a result, some salts, when they're dissolved, produce solutions that are acidic, some that are basic, others that are neutral. And you're going to have to be able to, when asked, uh, tell me whether a salt will produce an acid, a basic, or neutral solution. So the reason this happens is that the ions from the salts can hydrolyze water, which means to split it into its ions. And because of the other ions that are in the salt, there can be either an excess of hydrogen ion, which would be an acidic salt solution, um, or an excess of hydroxide ions, which would be a basic salt solution, or both, which would be, if they're both in excess, then it would be neutral. So you should be able to predict what acid and base the salt is made from, which we've already talked about, but also you should be able to predict the relative pH of the salt solution. So is it um, an acid uh, salt solution, a basic salt solution, or a neutral salt solution? So as you know from the indicators lab, when you tested the salt water, it was neutral. So when sodium chloride dissolves in water, um, it ends up with a neutral solution. Now, the easiest way to figure this out is to just think about what acid and what base produced that salt, if it were produced that way. So the negative ion comes from the acid, so Cl would combine with 1H to give us HCl, and then sodium combines, or excuse me, the base is produced from the positive ion, so it combines with hydroxide to produce sodium hydroxide. Then you have to ask yourself, are these strong or weak? So sodium hydroxide, it's an alkali metal, and bases made from those are strong bases, and HCl is the strongest of the strong acids. So strong base, strong acid, the strength of those two neutralize each other completely, so it ends up as a neutral solution. Here's an example, iron nitrate, of a salt that would end up as acidic. Well, how do we know that? Well, the iron um, produces a base that is weak, and the nitric acid, is one of the strong acids. So a strong acid will neutralize a weak base and end up with an acidic solution. What about a basic solution? Well, if we look at potassium acetate, potassium comes from the strong base potassium hydroxide, and the acetate comes from the weak acid, acetic acid. Okay. Now, if you're having trouble knowing whether a base or an acid is strong or weak, then go back and review the section on strong acids and strong bases. The lists of strong acids and bases are very short and pretty easy to memorize. Okay. Now, um, weak acids and weak bases, there's a wide variation in how weak a weak acid or a weak base is. So it kind of depends. If you have a salt like iron phosphate that's produced from a weak base and a weak acid, you have to know what the K values are to be able to say whether it be a neutral or acidic or basic. But for our purposes, we'll just say that it depends. And I'll try not to give you one of these on the test unless I give you the K value. So if one K value is like 10 to the negative eighth and the other is like 10 to the negative 12th, then it's probably going to be lean towards the side that is a little bit stronger. Okay. Now, the last topic we're going to look at are buffers. And buffers are solutions that do as the name implies. They buffer the pH of the solution. So what a buffer does is it resists the change in pH when small amounts of acid or base are added. So buffers are really important. We use them in chemical situations where we don't want the pH to fluctuate. And then we have buffers in our body that help to resist changes in pH. There's a buffer system in our bloodstream. There's buffer systems all throughout our body. Most body chemistry can only operate under a very narrow range of pH. So if the pH changes, then we would be in trouble and maladies would result. So how do we make buffers? A buffer is a mixture consisting of an aqueous solution of an acid-base conjugate pair. So there's two ways of making them. One is by mixing a weak acid with the salt of that weak acid, and the other is made by taking a weak base and a salt of that weak base, and that is what the conjugate base pair is, or acid base pair is. Okay, so this one is acetic acid and sodium acetate. So when we mix acetic acid with sodium acetate, we get a buffer solution. And what happens is that the acetic acid offers up hydrogen ion and acetate ion, and the sodium acetate offers up sodium ion and acetate ion. So if you look at this mixture right here, this is what is floating around in this solution. So there are, in addition to having OH ions, there are also these negative ions which are able to absorb excess hydrogen ion, okay, thereby preventing a fluctuation in pH. And then in addition to extra hydrogen ion, there's extra sodium ion, which can absorb OH ions, which also helps to moderate any fluctuations in pH.